possible in collaboration training center in Czechia and Slovakia. Now, first, I'm a cybersecurity student at Masaryk University in Brno, Czech Republic, and in my free time, I like to solve capture the flag challenges, especially hackabugs, and I would consider myself a passionate learner, as I like to learn one new thing every day, however small or insignificant it may be. Professionally, I'm a Python developer at the company Pentarep, which is a company I'll briefly introduce on the next slide. And at Pentarep, I'm responsible for the development of two security testing tools, which we'll talk later on, throughout the presentation. They're called PT-Elastic and PT-Kibana. Now, Pentarep. Pentarep is a penetration testing platform that combines both manual and automated testing. It provides checklists, automated tests, guides, team collaboration and management, and report generating. All of this to streamline your penetration testing process and make it much more efficient. If you'd like to find out more, you can visit our website at www.pentarep.com or scan the QR code shown on screen. I'll wait a few seconds for those of you who wish to do so. And now, what will we talk about today? The presentation is structured into two parts. First, we'll talk about Elasticsearch and PT-Elastic. I'll briefly introduce Elasticsearch, what it is, how does it work, and what it's used for. So for those of you who are already familiar with Elasticsearch, this part might be a bit boring. Then I'll highlight the importance of having your Elasticsearch secured. I'll mention some of the most common misconfigurations or security misconfigurations that I've found, and I'll show you the tool that I've created for penetration testing of Elasticsearch called PT-Elastic, and we'll have a quick demo. The second part is structured exactly the same as the first part, with the only difference being that the topic of discussion will be Kibana instead of Elasticsearch. I'll introduce what is Kibana, why does it need to be secure. I'll mention some of the most common security misconfigurations in Kibana, and then I'll introduce another tool I've created called PT-Kibana, which is a penetration testing tool for testing the security of Kibana instances, and again we'll have a quick demo. Okay, moving on to the first part. What even is Elasticsearch? Elasticsearch is a open source search and analytics engine, but not in the sense of a World Wide Web search engine such as Google or Bing. It's built to quickly find and analyze large amounts of data, your own data, the data that you provided. It's distributed, which means that if you have large amounts of data, think terabytes, you can distribute it evenly amongst multiple computers. We call them nodes in Elasticsearch, and then you would have better performance while searching through that data. It supports the data is either structured or unstructured, and it's in JSON. The way you interact with Elasticsearch is through its REST API, which usually runs on port 9200. And the fast search capabilities of Elasticsearch make it a perfect choice for app or website searches, log analysis, or security analytics. A real use case scenario of Elasticsearch would be, imagine you have a news website, right? You have a huge amount of articles which contain a lot of text. So you would store all of those articles in Elasticsearch, and then you would have a search functionality on your news website, right? You would have a little search box in the top right corner where users can enter certain keywords and look for all of the articles that contain that keyword. So when a user enters a keyword such as cybercrime, Elasticsearch would handle that request and return all of the articles which contain the word cybercrime really fast. Elasticsearch also provides additional functionalities which I think are important for my presentation. The two of them most important being authentication. Users can stores data is in documents and indices. A document is a basic unit of information. It's a data entry, okay? Think of it as a row in a traditional relational database. And the data is stored in fields with corresponding values. Now, a collection of these documents, these data entries, that have similar characteristics or are logically related is called an index. An index has mappings to kind of structurize the data, the way the data is stored in it. So here I've prepared a short, very amateuristic example of a university information system website. Right, you will have a website where the users and teachers can log in and browse information about the courses and the rooms. So we will have the indices for storing credentials. That will be the student index and the teacher index, and then another two indices for storing information on courses and rooms. The teacher index would have for example, this mapping. You would a teacher would have an ID, he would have a name and a username and a password which he uses to log in. And a document would be a specific data entry in that index. So here we have a document for a teacher whose name is James Dixon. He has the teacher ID of 1337 and he uses the credentials J Dixon and lucky123 ! To log in. Usually Elasticsearch isn't used as a standalone application, but is part of the ELK stack. ELK being Elasticsearch, which is used for data indexing and storage and search. Logstash, which is a application that processes and aggregates data. So you feed data into Logstash. The data you collect by whatever means you choose to. For example, another application such as Filebeat. You feed the data to Logstash. Logstash analyzes it, processes it, puts it together, and then sends it to Elasticsearch. And the last part of the ELK stack is Kibana. We'll talk about Kibana later on throughout the presentation. But for now, just think of it as a pretty graphical interface for the whole ELK stack. Okay, and now that we understand what Elasticsearch is, why do we need to secure it? Well, since Elasticsearch acts as a data storage, which can store data such as system or network logs, personal information or credentials, if we care about the security of the data, we need to make sure that Elasticsearch is secure and is accessible by us and only us. Right? The same way you would want to secure a SQL database. That's the same reason you want to have a secure Elasticsearch database. Another thing is that if Elasticsearch provides a search functionality or a search engine functionality, right? If you remember, I used the example of a news website where Elasticsearch handles the search box requests and searches. If an attacker would gain access to the Elasticsearch instance and would cause denial of service either by sending large requests to the Elasticsearch instance, or maybe he would delete the data. That would mean that not only would Elasticsearch be affected, but also the search functionality on the website will be affected. Okay, moving on. What are the most common vulnerabilities or security misconfigurations that are spotted in the wild? The first one is open access from the internet. Since Elasticsearch is an internal service, it should be treated as such. There is no real reason for you to have Elasticsearch open to the internet. So you should block outside access to it. If you really need to exit from outside, use a VPN or other tunneling methods. It is one thing to leave Elasticsearch open to the internet, and another thing to leave it open without any authentication. Newer versions fortunately come with authentication enabled by default, but some admins or people still decide to disable it. Some older versions of Elasticsearch also use the default credentials of Elastic and ChangeMe. So if you're using those, it is very advisable to change them. Or if you're a penetration tester or just a professional that dabbles in the security of Elasticsearch, you can maybe try those credentials and maybe you'll get lucky. Another common misconfiguration is unencrypted communications. There are a lot of publicly available Elasticsearch servers that are not encrypted by TLS or SSL, and this could cause an attacker to be able to read communications between the Elasticsearch server and the client, which could he could then capture credentials or the data being queried. And as I've previously mentioned, Elasticsearch has support not only for authentication but also for access control. You can create users, assign roles and privileges, but if you assign overly broad roles or incorrect roles, you could allow an user to access part of the system of Elasticsearch which you did not intend to. For example, Elasticsearch allows anonymous authentication, which means that users can interact with the Elasticsearch instance without providing any credentials. Now, and if we were to assign broad roles to that anonymous user, let's say we will give him the role of super user, which means that he can do anything he pleases to, this could cause trouble for us, as he could access anything he wishes to, as if there was no authentication intended or implemented. And the last thing is outdated software. Elasticsearch, just like any other product or software, has publicly known vulnerabilities. Some of them are critical, and some of them contain publicly available, or some of them have exploits available on the internet. This could compromise the Elasticsearch instance or even the machine hosting it. Now, personally, this is not that big of an issue in my experience, as most of the vulnerabilities that have public exploits available for Elasticsearch regard really old Elasticsearch versions. But still, it is good practice to keep Elasticsearch up to date and take vulnerability specific precautions. So if you are a penetration tester and you want to test the security of an Elasticsearch instance, there are a few tools that are available for you. One of them being Metasploit, which offers some modules for exploiting vulnerabilities. Again, these are quite old. As you can see, some of them are from 2015 or even 2013. And it has also some enumeration modules. You can enumerate the version of the Elasticsearch instance, the node and cluster information, the users available on that Elasticsearch. Nmap also has a script for enumerating indices, plugins, and cluster information. However, I'd like to suggest an alternative, PTElastic. Now, what is it? PTElastic is a security tools for identifying, fingerprinting, and exploiting vulnerabilities in Elasticsearch. It is written in Python and developed primarily by me and Daniel Kumel, which is my colleague. It is part of PT Tools, which is a collection of security testing tools by the company Pentapp. Now, the functionality, or what can it do? What can PTElastic do? Firstly, it identifies whether or not Elasticsearch is even running on the host, and whether or not it is running on HTTP or HTTPS. It identifies if an Elasticsearch instance has authentication enabled, and if it does, it probes for anonymous authentication. That means if it supports anonymous authentication. It also has enumeration capabilities. It finds out the version of the Elasticsearch instance, the different plugins and modules, their versions, which are installed on the Elasticsearch instance, and it prints out a comprehensive list of users, their roles and privileges. It also tests or exploits for CVEs, which are quite old. Two of them are RC vulnerabilities, and two of them are directory traversal vulnerabilities, which allow arbitrary file read. PTElastic also pulls CVE data related to the version of the Elasticsearch instance that we're targeting, and returns a list of CVEs. It also dumps data from the available indices and maps out the index structure, right? It prints out the mappings. Now, I would like to quickly show you the tool, how it works and how it operates, so that maybe you can understand it better. For context, I have a Elasticsearch instance running in the background, and to run the tool, we run it like this, and we can see how it's used. We need to specify the host that we want to target, and we can also specify the tests that we want to run, maybe a proxy, and we also can specify some credentials or files or test specific arguments. Okay, so let's use as target the local Elasticsearch instance that I have running in the background, and we can see that we did not get much. A lot of most of the modules have output with an OK icon, which means that it's okay from a security perspective, right? We're not able to find any vulnerability. The only one we were really able to find was that the host is running on HTTP and not HTTPS. And we can also see that authentication is enabled. So we need to authenticate somehow, and as I mentioned previously, a lot of older versions use the default credentials of Elastic and ChangeMe, so we'll try those and maybe we'll get lucky. And as you can see, we get much more output now. So I'll quickly go through it. So you can see again the HTTP test. So most of the, or all of the exploitation modules were not successful because the version is newer than the version of the Elasticsearch that is vulnerable to those vulnerabilities. You can see that the Elasticsearch version is 77.14.0. Some modules that are installed on there. Most of these are the default modules which come packaged with Elasticsearch. And here you can see the user enumeration module. We authenticated as the user Elastic, and you can see that we have the role of the super user, which means that we have all privileges on all indices. We also can see some other users such as structure and data dumping modules. You can see that we found 3 indices. The first one being teachers, second one students, and the third one exploit. The exploit in the index was created by us when we were trying to exploit the CVEs. But the indices teacher and students were there before. And you can see that the data dumping modules dumped all of the data that was stored there, and we also found some vulnerabilities from the National Vulnerability Database. If we want to maybe dump only part of the data from the indices, we can choose to do so. For example, let's say we want to only do credentials, right? So we want the username and the password. So firstly, we would want to specify that we want to run only the data dumping module. We want to dump the index of teachers, or is it teacher? Yeah, teachers. And we want to dump the fields username, password. You can see, as you can see, the tool dumps only the username and passwords, and of course the document ID and what index does it belongs to. You can also choose to redirect the output to a file, open it, and the output is in the file. Maybe that's better for further parsing if you choose to do so. Also, the whole script has the whole tool has a JSON output, or a JSON object that it fills with data throughout its execution. So if I run it with JSON output, we can see that here we have the Elasticsearch version that we found, the vulnerabilities that it's vulnerable to, the different modules that we found, their versions, and so forth. Okay, now that we have an understanding of how Elasticsearch can be left vulnerable, I'd like to mention an actual data breach that was caused by an insecure Elasticsearch instance. It was on May 9th, 2025, and it regarded a Swedish business intelligence company. They were hosting over 100 million records of financial and behavioral data on Swedish citizens and organizations. The data included full legal names, including the history of previous names, Swedish personal identity numbers, and financial data. And it was caused by open access from the internet and missing authentication. Right, someone left the Elasticsearch instance open to the internet. Someone probably just found it through Shodan or whatever other means and went through the data. Here is my personal finding that I found during my work on PT-Elastic. I found a ransom note on multiple Elasticsearch servers that were public. You can see here that there's a message, your database has been backed up, blah blah blah, pay us Bitcoin, and so forth. So yeah, ransom or extortion is also a possibility if your Elasticsearch instance is not secure. Here is a screenshot of a showdown report. I took the screenshot in October, at the end of October, and it shows that that there were around 9,000 publicly available Elasticsearch instances, most of them being in China, United States, or Germany. Now, a quick recap to close the first part of the presentation. Elasticsearch is a search and analytics engine that stores data in JSON. It's used for business intelligence, security analytics, log analysis, website searches, and many more. It provides some security functions or configurations such as authentication and role-based access control, which are sometimes left misconfigured, with the two most prevalent misconfigurations being missing authentication and open access. And if you are a penetration tester or other penetration or other security professional which works with Elasticsearch, I recommend you try out PT-Elastic, as it automates some of the tests that you would normally do when pen testing this tool, or when pen testing Elasticsearch. This brings me to the second part of my presentation, where I will talk about Kibana and security. To start off, what even is Kibana? As the motto, your window into the Elastic Stack, implies, it's a graphical interface for Elasticsearch, right? It's a front-end application. Its main purpose is data visualizations. Right? It provides graphs, pie charts, maps, and other structures to visualize the data stored in Elasticsearch. It normally runs on port 5601. It's part of the ELK stack, and it also provides some stack management capabilities, meaning that you can edit the users, their roles, you can edit indices, and view the mappings of indices in Kibana. And you can directly query the Elasticsearch data through the developer tools, the developer console to be specific. And what's interesting is that it can act as a proxy to Elasticsearch, obviously, because it has to have access to Elasticsearch data. But this means that if you have, let's say, a server is hosting Elasticsearch and Kibana, and the Elasticsearch instance is behind the firewall or whatever, it's not accessible from the internet, but the Kibana instance is, and an attacker is able to access that Kibana instance. That means that he can also indirectly or through proxy access Elasticsearch. Here's what a default configuration of Kibana looks like. And here's a more customized Kibana dashboard. This one being a firewall monitoring dashboard, to be specific. Now, onto the importance of securing Kibana. Since Kibana is just a front-end application for Elasticsearch, all of the security implications that apply for Elasticsearch also apply for Kibana, with the only addition being that since it can serve as a proxy, we need to make sure that it's secure, because we have a possibility of an attacker accessing Elasticsearch, an unexposed Elasticsearch instance through an exposed Kibana instance. Not only are the security implications very similar, the common security misconfigurations are practically identical, so I'll just skip through them quickly. Since Kibana is a front end for Elasticsearch, it is also an internal service and should not be less accessible from the internet. It should not also be left without any authentication, missing authentication and open access from the internet is unfortunately still kind of prevalent on the internet. You can access a lot of Kibana instances without authentication. We should also enable TLS or SSL, make sure that proper access control is in place, and try to keep our Kibana instance updated. Regarding the existing tools for penetration testing of Kibana, the options are quite slim. The only tools that I've personally found was two modules for exploiting a CVE in Kibana in Metasploit. Which brings me to the last topic of my presentation, and that is PT Kibana. PT Kibana is a tool that identifies fingerprints and exploits vulnerabilities in Kibana instances. It's written in Python by me and my colleague Daniel, and is also part of PT tools, which I've mentioned before. Think of it as the Kibana equivalent to PT Elastic. PT Kibana and its functionalities, it identifies if Kibana is running on a host and whether it is running on HTTP or HTTPS. It identifies if it has authentication enabled, enumerates the users and their respective roles available on Kibana, and the plugins running. It also pulls CVE data from the National Vulnerability Database and prints the found CVEs related to specific Kibana version. It also identifies if the Kibana instance can serve as a proxy to Elasticsearch, and if yes, it runs PT Elastic through the proxy. So it's kind of a situation where we merge the two tools together. It tests for a CVE, or rather verifies if the host is vulnerable to CVE 2019-7609, and it maps out the data structure of Elasticsearch running with Kibana. Rather, it prints the structure of the indices. And just as we did with PT Elastic, I'd now like to have a quick demonstration of the tool. So again, I have a Kibana instance running in the background. We'll launch PT Kibana. Oh, sorry. Okay. We'll launch PT Kibana, and we can see that again we have to provide the host. We can specify what tests we want to run and some test-specific arguments. So we'll launch it in the default configuration. And we see that we haven't got very far, since as you can see here, the Kibana instance has authentication enabled. So again, we'll try the default credentials, and again we succeed. As you can see, the tool first identifies if Kibana is running, then if the proxy is available, and if yes, then it runs PT Elastic through the proxy. As you can see, these are the test or the same test or modules that we ran when we were having a demonstration for PT Elastic. So again, we have user software enumeration, user enumeration, the data structure test, what indices are available. You can see that this is a library, or it's the Elasticsearch serves a library system, and we dump the data. Here you can see what kind of bugs they have, and some customer data. You can also see the available plugins, Kibana plugins, what kind of version of the Kibana is available, is running on HTTP, and we also have some operating system information, you can see that this Kibana instance is running on Linux, CentOS to be specific. User enumeration was skipped as it was done by PT-Elastic, and the same with data structure tests. And you can see we found quite a few CVEs from the National Vulnerability Database. And this brings me to the end of my presentation, and I'd like to quickly summarize the topics we've covered. Most importantly, how to test for common security misconfigurations in Elasticsearch and Kibana. So, Elasticsearch is a search and analytics engine that stores data in JSON. It usually runs on port 9200 and uses a REST API for interaction. It is sometimes left misconfigured in the sense that it's left open and accessible without any authentication. Kibana is a front-end application for Elasticsearch that provides visualizations. It runs on port 5601 and is also sometimes left open without any authentication. And if you're a penetration tester or a security professional and you'd like to automate the testing of Elasticsearch and Kibana, or maybe you just want to expand your arsenal, I would like to recommend that you try out PT-Elastic or PT-Kibana, as I believe it provides some functionalities that other available tools such as Metasploit or Nmap do not. For example, Metasploit or Nmap do not enumerate privileges for the different users and their roles, or they do not dump data or print the structure of the indexes. I'd also like to thank GoPass IT Training Center for making it possible to make this presentation become reality. And if you are interested and you'd like to expand your knowledge in cybersecurity or just your general IT skills, I recommend you go check them out, as they offer some really nice courses for IT professionals, security professionals, programmers, and many more. They also provide some or offer some certifications. And finally, I'd like to thank you and all of you for your time and attention. It's been a great pleasure for me, and if you have any questions, I'd be more than happy to answer them now. Also, if you want to get in touch with me, feel free to do so through my LinkedIn. I left a QR code on this slide, which you can scan. Yeah, so thank you.
Marker?